We'll look at trig integrals in far more detail in the extension 2 work, but here's just some initial ideas for extension 1. So basic integrals which involve trig, well, so far we've seen that the integral of sine is minus cos, and integral of cos is sine, and the integral of sec squared is tan. We've also seen integral of tan x, we can rewrite as sine on cos. That would be the minus the log of cos, or the log of sec, your choice of course, which you prefer on those. And as I mentioned before, not a bad idea of memorising those because that could save some time. This other one, the integral of sec tan, used to appear on the very old standard integral sheets, but it doesn't appear on the new resource sheet. But the integral of sec tan turns out to be sec. So it's another one that is worth remembering. Complementary ratios then. The integral of a complementary trig ratio will equal minus the complement of the answer. Let me show you what I mean. We know the integral of cos x is sine x. We know that already. But cosec squared, it'll be minus cot. Right? Cosec is the complement of sec. So sec squared gave us tan. So the complement of sec squared, cosec squared, will give us minus the complement of the answer. The complement of tan is cotan. So it'll give us minus cotan. The integral of cot then, remember the integral of tan was minus the log of cos. So cot, the complement of tan, so it'll be minus the complement of the answer. So we'll get positive now, log, and instead of cos, it'll now be sine. And I just said that sec tan, the integral of sec tan was sec. Well, cosec cotan, so the complement of the integral, will be minus the complement of the answer. Well, the complement of sec is cosec, so we get minus cosec. So here's tan x. That's what I was getting at. We know tan x is the log of sec. Integral of cot, therefore, cot is the complement of tan. So the answer is minus the complement of sec, which is cosec. We get minus the log of cosec. So, I guess what it means is, if you remember that idea, is you only sort of need to memorise half of the integrals, because then you automatically get the complement from the same one. Squares of trig functions. Well, we've seen this one already. Integral of sine squared, we can rewrite sine squared as half the integral of 1 minus cos 2x, which then becomes x on 2 minus a quarter sine 2x. I'm not suggesting you would memorise that one. Cos squared we can rewrite as a half of the integral of 1 plus cos 2x. So we get x on 2 plus a quarter sine 2x. Now, notice this. Remember, sine 2x you can rewrite, if you wanted to, as 2 sine x cos x. So another way you could write the first answer there is x on 2 minus a half sine x cos x. And the second one you could write it as x on 2 plus a half cos x sine x. It's pretty rare you do that, but it may have its uses depending on the question. Sec squared, well, that's a standard one, which is tan. Cosec squared, well, cosec, the complement of sec, so we get minus cot. Tan squared, well, tan squared we can rewrite as sec squared minus 1. Integrate sec squared, you get tan x, integrate the 1, you get the x, so it's tan x minus x, which means cot squared should end up being minus the complement of that. So we could rewrite it as cosec squared minus 1, and we get minus cot x minus 1. Notice that minus x is still minus x there. It's only minus the complement, the bit that contains the trig ratio. So integral of cos squared 3x, well, I'll rewrite that as a half of 1 plus cos double angle 6x. So we get x on 2 plus a 12th sine 6x plus, of course, a constant. Sine x cos 2x. Ooh, well, I could use product to sum. And so the sine x cos 2x I could rewrite as half sine the sum, x plus 2x is 3x, plus the sine of the difference. Now the difference has to go in the same order. So it's x minus 2x, so sine of minus x. Well, sine's an odd function, so I could rewrite the sine of minus x as minus sine x. But I now have two functions that I can integrate. And sine, of course, goes to minus cos. Sine x cos cubed. And this is a definite integral, this one. But I notice it's in the form derivative times function to a power. The derivative of cos x is minus sine x. So if I balance that out, I'll get minus out the front. And then I've got the derivative minus sine x. And so it'll be add 1 to the power over the power. Cos 4, that should be minus cos 4, shouldn't it? Oh no, because notice what else I've done. I've swapped the limits around. So that's why I don't have minus cos to the power of 4, because I've swapped the limits around and made it positive. Sub in the 0, sub in the pi on 4, and we get our answer. Okay, so 12C are just a, well, handful there, big handful of trig integrals to look at.